All right, so we want to look at this example. This is not in your textbook. It's just so we can make an observation of what's going on and make sense of the theorem that comes after this. So one thing we're going to look at, we're looking at this function f of x, x squared plus 5, and we restrict the domain to be from 0 to infinity so that this is a one-to-one function, and then we can find its inverse. So let's go ahead and find the inverse. Get rid of the function notation first. We switch our x's and y's, just like we learned in college algebra or pre-calculus 1. And remembering this whole time that your x is greater than equal to 0. Once you switch your x's and y's, you switch it in the condition as well. So you now make it y is greater than equal to 0. Continue. Solve for y. So y squared is x minus 5. And now we're going to take the square root of both sides. Y is going to be equal to plus or minus the square root of x minus 5, except that we need to go ahead and apply this condition that says y is greater than or equal to 0, which means we're going to restrict this to only the positive square root of x minus 5. And this is f inverse of x. For the sake of this example, to kind of help you to keep things straight, we can call this g of x. So g of x is equal to the positive square root of x minus 5. All right, now the next part of this example is for us to find f of 3, and then to find where g of x equals 3. So f of 3, remember that's our original function, is 3 squared plus 5, so that's 14. Then we want to know where g of x equals 3. Well, your g of x is square root x minus 5, so we set that equal to 3 and solve. We're going to square both sides. To do that, we get x minus 5 equals 9, and x equals 14. Okay, so you can see that for the f function, the point AB on the graph means that g, which is the inverse function, tells you that the point BA is going to be on the graph. So this first part here is just college algebra or pre-calculus 1 material to know. Now the next part we want to do is to find f prime of x and g prime of x. So just the first derivative, f prime of x is going to be 2x. G prime of x, which is f inverse prime of x, is going to be 1 over 2 square roots of x minus 5. You can take as many steps as it takes to get there, but I'm just telling you this is what we're going to get. And now let's see if we can find f prime of 3 and g prime of 14. So f prime of 3 is 2 times 3, which is 6. And then let's find g prime of 14, which is f inverse prime of 14. That is 1 over 2 times the square root of 14 minus 5. That's 1 over 2 times the square root of 9. Square root of 9 is 3, times 2 is 6, and that is 1/6. So what do you notice about these? We notice that those end up being inverses of each other. So this is what the the theorem 3.21 is saying for us about the derivative of an inverse function. If f of x and g of x are inverse functions of each other, so that g of x equals f inverse of x, this means that if the point AB is on the graph of f of x, then the point BA is on the graph of f inverse of x. Theorem 3.21 says that f inverse prime of A is going to be equal to 1 over f prime of B. So what this means to us is that we do not have to find the inverse in order to be able to get the derivative. Okay, so let's try it with this example. We have this function f of x equals the square root of x plus x squared plus 1, and it's 1 to 1 if we restrict it to be x greater than or equal to 0. It has an inverse on that interval, and we are trying to find the slope of the curve at the point 3, 1. Now remember what it means to find the slope of the curve. It means we're going to have to find the derivative. Okay, so what they're saying here, if we have f of x equals the square root of x plus x squared plus 1 for x's greater than or equal to 0. Okay, here we are. F of x and g of x are inverses. Okay, the theorem 3.21 says that f inverse prime of A is going to be equal to 1 over f prime of B. Well, that is what we're being asked to find here. They're asking us to find the slope of the curve, which means f inverse prime of x. Okay? And they have given us this 0.31. So specifically, they're saying f inverse prime of A, which is 3, this is a 0.31, f inverse prime of 3 is going to be equal to 1 over f prime of B. So we can get straight to this by just finding the derivative of f. We don't need to find the inverse of f and find the derivative of f inverse of 3. Okay, so we're going to come over here and we'll find f prime of x, just the first derivative of the function. So this is going to be 1 over 2 square roots of x plus 2x, and the derivative of 1 is 0. So there is our derivative of f. Okay, so we're supposed to find the slope of the curve f inverse of x at this point. So f inverse prime of 3 is going to be equal to 1 over f prime of our b is the 1. This is this point right here, a, b. We found the inverse over here. So we're going to take that 1 and put it in. So f prime of 1 is equal to 1 over 2 square roots of 1 plus 2 times 1. So this is 1/2 plus 2, which is 5/2. So I know this is going to be 1 over 5 halves, which is 2/5. So this is the slope of the curve y equals f inverse of x at the point 3, 1 by using theorem 3.21.